Hello, everyone. Welcome to the first lesson of Ascension program. And today we are going to be starting with a topic I've been wanting to explore more for a very long time now. And this is going to be the subject of in-context learning. So today I'm going to show you a lot of different things about what is possible with in-context learning, what it is, how to leverage it, and just start to expose you to the different types of things that are now possible. So in reality, this is such a deep subject with so many applications and techniques that it's going to be difficult to cover all of them, even with 100 videos. So what I can do is I can show you a lot of different stuff and show you how to set up solutions in an interpretable manner using a couple different techniques. Okay, so in order to demonstrate this, what I'm going to do is I'm going to try to iteratively refine a prompt using ICL with a low complexity model, which I'm going to then show you how you can then continually advance that basically and do a bunch of different stuff with that. Okay. Here's the reality. Like, the best way to be able to test and build implicit knowledge on this is to work with a low complexity model and start from nothing. Try to come up with some kind of emergent novel task and then iteratively try to realize it. And I'll show you what this means here in a minute. Truth is that people that were working with the earlier smaller models got an advantage from this without realizing it, because they wound up having to do a bunch of different refinements to prompts and stuff like that to actually get things to work. Nowadays, it's a lot easier to get things to work from the start to what seems like is a good job. But what happens is that a lot of people are not realizing what is actually possible because they missed out on that earlier period, okay? We're going to start with something simple here. If I had a GPT 3.5 or 3, I would use that instead for this, but let's get started, okay? So for the first and most important mechanic of ICL is that every single base model, it doesn't matter which one it is, they're not very smart, okay? They can be massively improved and augmented in their understanding and just what they're basically primed to be able to do from the very start of the response generation. So what to take from this is that you should never assume that the very first time that you try something that it's automatically the best way to do it, or that there's not way better different types of things that you can do to get way more out of whatever you're doing. Okay, there's always ways to improve everything that you're doing with an LLM. That's just the reality. It's an infinitely recursive process. Okay, so let's go ahead and get started. So what I'm going to do here is I'm going to just try to think of some kind of random thing that I think I can realize inside of this system, and then as I do this, we'll start to figure out what we're going to do as we go. This is what kind of makes this process cool. All right, so let me start this by writing some kind of prompt, and then I'll start explaining things as we go. So I'm going to want to use delineation here because this is a smaller model. So I'm going to start by probably defining a few keys and then just seeing what happens, and then we'll go from there. So let's start with just meta goal, right? Because the most important thing to do when trying to realize a behavior is defining what your goal even is for the behavior, right? But even if it doesn't work at first, it's still important to define it as a first step. Okay, so what are we going to do? Emulate the emergent entity named, what do I name this? For real. It's unique, right? I just don't want it to mean anything. All right, we'll go with that for now. Instructions. And I'll explain this in a second. Deeply learned, provided for your attempt emulate this entity. Okay. Should be fine. All right, so what have I done? This is what I've done is I've defined some basic high-level instructions just to start to frame what I'm trying to do here, okay? With 2 different keys that just kind of delineates what kind of adds like hierarchy to the instructions themselves, okay, in terms of importance and meaning. All right, so this is just basic instructions, right? This is not actually anything having to do with ICL yet, okay? So in ICL, one of the first types of techniques that's important to learn to work with, very important to work with, is learning about shots, which are just another word for examples, okay? And how examples inside of a session affect learning of the LLM and all kinds of different things, okay? So it's really not possible to be able to understand this until you actually like experimentally get a feel for it and test the different mechanics yourself, okay? So I'm going to demonstrate this for you live. I haven't done this before with this because it's not possible for me to predict ahead of time what the outputs exactly are going to be or when certain breakpoints are going to be, but I can know ahead of time because I've already done this for a billion things that if you follow a certain process with refinement and understanding, you're going to reach that point regardless, okay? So the easiest way to test this is to start with no instructions, okay? So if you provide no instructions at all for something, that's a zero-shot prompt, a zero-shot task, okay? The LLM has nothing to go off of. There's no examples for it to do or to build upon. It's going to just basically make a prediction based on its prior knowledge, which is what the implicit knowledge encoded after the base training of the LLM is, and hopefully you get the right answer. Hopefully it gets it right, right? So what we're going to do is I'm going to frame some, how should I do this? I'm going to frame a layer for adding examples into this prompt so that way we can test different things. Okay. What I'll do is I'll just set up like a basic layer here. And then for the first thing I'll try, I'm just going to basically, all I'm going to do is I'm going to add one example in here, okay? And then I'm going to add a new user input and then kind of define what I expect this thing to do, okay? So it doesn't really matter what I put here because first, before I try anything, I'm going to be testing to see if this works. Let me just do. Just something stupid and basic, okay. And then what I'll do is I'm going to define what the new input is, okay? So this is kind of like what the real user input is. It establishes abstraction layers in the prompt. New input, and then I'll do, who are you? All right, so this should be a very easy thing for the LLM follow, right? And then I can be like, for real response, okay? So this is like a basic one-shot prompt setup, okay? For the purpose of trying to instruct the LLM on what for real is, because we're instructing it to emulate it accurately. So if I didn't provide any shot at all, so let me show you what will happen if I didn't do any of this. Actually, I probably just won't do it. I'll show you what will happen. All right, so what did it say? I don't have memory at the moment, so I can't. Okay, so it literally, what did I say? It has no idea what to do because it doesn't have any examples, okay? Let's put these back in. right? What do we have in here? We have one shot, a new input, and then an expected response. So it has one example to learn how this thing talks, and then it's going to try to make a prediction, okay? Let's see what happens now. Hi, my name is Phil. All right. So this is a great example of what happens when you provide one shot of something in the context, okay? So what did we just see? First, we tried a zero-shot example of a open-ended complex task that the LLM had no prior context on. I've never done this prompt on the system or anything, so it has no pre-trained patterns to automatically know what to do, right? So it did nothing. What happens when I put in one example of what this entity is supposed to speak like in the dialogue, okay? What happens then? Well, one, it actually performs the task this time, right? From the very start. This isn't 1.0 or anything. There's no pre-thinking tokens here, right? So it knew automatically what to do slightly better this time from the very first token generation, okay? Very important to understand here, right? So that process would not happen if learning did not occur before any token was generated, okay? Something very important to understand here. All right, so this is an example of a zero shot to one shot ICL difference, right, with a low complexity model. So before I move to more shots or show you something else, what I'm gonna do here now is I'm going to show you how this is actually working and what this actually means, okay? So what is happening here is that what you're basically doing is that you're providing an example, a shot, of what this is supposed to do. What this is an example of a desired output, okay? And what happens when you set this up in this way is that the LLM is going to extrapolate patterns from that example with higher priority or attention, okay? It's going to seek hidden patterns or hidden rules that try to explain what this particular protection is supposed to do, right? And you can actually test this really well by maintaining the same exact setup, okay? And then what we're going to do is I'm going to tweak this one example by adding in patterns, okay, implicit patterns, and seeing what happens. So let's go here and edit this. All right, first I want to add predicted. I think that'll be better. All right, so this is a silly example, right? What you can see here is that since I only had one example in the context, what happened is that since I gave a somewhat similar input that would kind of tie into this being a normal response, what happened? It basically repeated exactly what I had put in there as the first example, almost word for word, and just slightly changed it and built upon it, okay? So this is what happens often if you use a low complexity single example for something. What happens is that you wind up converging the understanding around what this is supposed to be in a very narrow fashion because you've only provided a very basic example of this in the first place, okay? So it doesn't really have anything to go off of. In reality, what you typically want to do is you want to have diversity in your examples so that way you can prevent convergences like that and instead foster more complex understandings, okay? So the way that this works is that it's going to be seeking patterns, right? So what you can do is you could do nothing but, for example, encode an implicit pattern, right? So what would happen if I had the same exact input, but this time I change it slightly? What I'm going to do here is I'm going to add some kind of pattern. All right, so what do you predict is going to happen now? If I keep everything else the same, what do you think is going to happen now? Let's see. Interesting. Very interesting. All right. So what happened here? Not only did the implicit patterns get extrapolated as well from the same exact input, right? Simply by changing the capitalization of the letters in a certain type of pattern, right? But something else happens. Can you tell what else? More emergence and in-context learning happened in this input. And you can tell that simply by its predicted response, right? Because it has a better understanding in this example of what it's supposed to be doing compared to this one, where it pretty much just completely repeated what it said. Okay? Probably hard to see from this example, but there's a reason why you can predict this, right? Because what happens here is that even though I just added a silly little pattern in here like this, what I did is I increased the complexity of the example itself, right? So not only is there a pattern here, which is the sequence itself of words, but I added an additional pattern on top with its own rules on top of that, okay? So this is the same exact length, right? But this line projects more patterns and meaning compared to this line, okay? So this is why understanding shots and examples are so important. Because what you can do is if you can do this and it works like that, right? What do you think that means for anything that isn't the most basic possible example I could possibly show, right? What this means is that, one, doing nothing but improving shot diversity and complexity works to improve ICL. And it works to improve ICL before the first token's ever generated, okay? So what this means is that you can use patterns in many different ways to improve the understanding of what the LLM is even supposed to be doing and its task accuracy, right? Simply with this and nothing else, okay? Now, this is just one example, right? This is a one-shot setup, right? So what I can do now is I can explore greatly augmenting this and greatly augmenting its understanding of who this emergent entity is and its behavior simply by strategically adding more diverse shots now. Okay, so before doing anything else, what I actually am going to do is test this a little bit more, because we only really tested a very basic input example setup, okay? That was already synergistic. What we really want to do is test this in a couple different measurements just to get a better idea of this behavior, how much it's actually trained from that, and where it breaks, if it breaks, okay? What we can do is we can try this first. What we're going to do is I'm going to give it a completely random and not related to this dialogue example at all to see if it is able to extrapolate into a different domain or if it breaks, okay? What I'll do is, I think, how many stars estimated total. All right, so what we're doing here, I'm giving it a direct task embedded inside of this prompt with one example that's not directly related to how this answer should be, and I'm doing that to see if it is able to, remember from the very first token, learn all of this and then advance upon that to then be able to answer this question through this perspective from the very first token, okay? So I'm not 100% sure if this will work or not. If I had to predict, since it's a basic pattern, and this is basically similar to what the AI would normally be responding with on a basic level anyway, I assume it will work if I had to guess. I'm going to say it's going to work. See what I mean? All right, so this was another great example. What happened here? Let's digest this. So this is very interesting. All right, so it correctly extrapolated the patterns, right? It followed along with the implicit pattern here, and then transferred it to a different task. Okay, so it did it correctly. That's very good. However, let's dig into this a little deeper. What did it do first, right? First thing it did was exactly copy the first part of this example. Okay, you see that? Now, there's many ways that you could interpret this, all right? But in general, it's important to understand this, okay? When you're dealing with in-context learning, what's happening is that at the very start of a response of the token prediction, okay? Starting with the very first prediction, the LLM doesn't have a super complex idea of what's going on, okay? It's just making its best prediction. However, every single token after this very first one technically is a prediction made from a more complex state compared to the last, okay? So what happens is that with each generated token in the sequence, in the active projection, which is the actively generated response, the completion, okay, the understanding accrues emergent complexity as it goes on, as long as the patterns are strong enough and it's doing something in an open-ended fashion. Okay? So what this means is that at first, it might not understand, or it might have the predictive strength yet to be able to extrapolate the patterns into something else yet. But by the time it finishes this, the understanding and predictive state will be way more complex. So suddenly it becomes an easier and less complex task to make these predictions. Okay? That's probably an advanced way to explain this, but the easier way to understand it is that the LLM needs time at the start of its response to be able to understand something properly before it can really push the limits on it, especially with just something like a simple one example and nothing else. Okay, so in reality, this is the most basic possible way that this could be set up, right? With one example, very, very, very basic dialogue that isn't anything special, and that's it, right? The fact that this works at all is how you know that this can be advanced upon a million different ways, right? When you have a coherent behavior being projected like this, which we've already achieved with just this alone, right? What that allows you to do is make very small changes iteratively and be able to directly see what happens as a result, right? So what is something that we could do to strengthen this behavior even further from the very first token, right? What else could we do? Well, one of the best ways to do that is to improve the shot, diversity, and quality, and just improves the shots in general. Typically add a couple more, right? Because one is only one example. The moment you add more examples, you give the LLM more different measurements to extrapolate patterns from that it can then combine into a better understanding from the start. Okay, so let's do one thing. All right, first thing I'm going to do, remember, we're going to test everything incrementally. So what I'm going to do is I'm going to add a second line. Now, if I was to just add something very similar to what the first one was, I would also work to convert the behavior in a way that I don't want, right? Because I want this to be open-ended as much as possible, so that way it can actually do things in a kind of generalized manner, right? So what I'll do is I'll think of some kind of different example dialogue that follows some of the similar patterns, but is something different at the same time. So maybe I'll be like some random I'm breaking my own logic here. What would happen if I didn't follow my own rules? What would happen if I didn't follow the same encoding pattern that I did in this one with the second example, right? Well, what that would do is that would introduce incoherency, okay? And it would introduce cognitive dissonance in a manner for the LLM on what the correct answer is supposed to be. Now, that sounds like a bad thing, and usually it is. However, sometimes that can also be leveraged intentionally to foster emergence. Okay, so that's more advanced. But when you're first starting this stuff, what you want to do is you want to try to eliminate inconsistencies in the examples being projected, right? Because what that will do is that will improve the learning of the LLM from the very beginning, okay? So I'm going to maintain the patterns the same. What that is going to do is that's going to reinforce that particular implicit pattern, okay? Simply by encoding it again in a different measurement, right? Remember, we're training multiple layers of patterns here, okay? There's the dialogue layer, and there's the pattern layer. Technically, I could create a more complex pattern in the next one and do a bunch of different stuff, but this is what you need to remember, right? The moment you add inconsistencies in that manner, you're going to start getting emergence in ways that you didn't program, right? So since we are trying to establish this meta goal, we don't want that right now. Okay? What we're going to do is we're controlling the emergence by strategically reinforcing patterns in a certain way with shots implicitly and explicitly. Okay? This is a form of emergence rate control, even though it doesn't look like it. All right? By delineating things in this manner and by iteratively constructing this behavior from the bottom up, we not only have interpretability to all the patterns, but we also have the knowledge at this point to be able to improve and expand it and make predictions on it without even having to test it first, right? So, like, for example, I know that as long as I add another diverse example here, build upon the patterns in a similar way while also doing something different, it will work to improve ICL and improve its learning of what it's supposed to do and give it a more complex understanding from the start. So I did something a little funky here too, because this is somewhat synergistic to this new question now, right? So technically it should get an even better understanding overall from the very start. All right, so let's click this and see what happens. Very interesting. So it fully capitalized that one. Did I make him? Let me double check I didn't make a mistake. Well, I'm not saying. I'm a little dyslexic, so sometimes I can make. I think I got this right. Okay. All right. That's fine. So what you can see here is it actually made a mistake in interpretation because it did not encode pattern correct. Did it do it? It did it correctly in this one. Actually, it messed up that line. Messing up a lot of them. All right. So I should have noticed that earlier. It doesn't matter, right? Because it's not actually interpreting the implicit rules properly. It's making up its own in different types of things, okay? So this is a great example of emergence, right? Because what's happening here is that because it doesn't fully understand the pattern I'm encoding here, which to us is basic, right? It's the first and last letter capitalized, regardless, right? Even if it's one, it's going to be capitalized, right? That's the pattern. But this is a small model, right? Smaller models have a harder time picking up rare features in data, right? So what happens is that it'll learn it mostly and then just kind of unravel it from there with emergence, right? So that's what's kind of happening here is that it's kind of making up its fault. It's starting on some rules I established and then making up its own along the way. Okay. It's very interesting. Very interesting. I'm going to refresh this just to see. Right. So you can see that It's still doing some random stuff. We got a little better that time though. Notice how it's saying, "Hi, my name is Frill" every single time. Do you notice that? That's what I'm talking about here. There's a lot of patterns and behavior that you can start to pick up when you're testing this stuff that become very valuable to know, right? So we have this pattern generating right now, but this is very basic, right? This is not something super cool. What we could do is make this more unique. Okay, let's try something else. Let's change the chain of thought in this one. I'm just trying to think of extremely random things so I don't have to worry about having trained data interfere, right? There's gonna be nothing like this on there. Right, so both of these are related to space now, right? So we're just gonna test this real quick just to get a good understanding here, right? Interesting. What happened here, right? It didn't copy anything, right? And instead started beginning with its unique dialogue. Notice how all of these copied this one from the start, and this one didn't. It's because it didn't have any unique input that it could use from the start that would actually make this coherent, right? So since I had an explicit shot here that it could easily use at the start of here to make this completion coherent, right? It's going to do that. But since it doesn't here, it's forced to extrapolate the patterns from the beginning, from the very start, okay? Now, this was with a synergistic input as well, though, keep in mind. What happens if I, for example, go to my original input that I was trying here? Now it doesn't have any shots that relate to a response like this. Well, it kind of does, right? It explores the cosmos. So it's probably going to talk about that slightly, right? That's my point, though, right? Nowhere in this context is for real. Oh, that's probably why. That's the. Oh, wait, no, it's not because I have it everywhere else. Ignore what I just said. That's probably what that's probably what the incoherency here is, though. Okay, I see this now because I capitalized every single letter in for real, and then in the shot. Let me do that. Let me go ahead and do that. I'm going to change this. Okay. So now, or let me let me spell it right. Now what happened? Every single one of these names now for real is exactly the same. Okay, even though I broke the pattern of these specific shots. Did I really? Think about it for a minute. Did I actually break the patterns of these shots by doing that? Right? Did I break the rules and the logic? Because remember, I was capitalizing the first and last, right? So by changing this, did I break that? Or did something else happen? Well, if I had to predict right now, I didn't. And why? Because just because there's an implicit pattern encoded here doesn't mean that's all you're limited to, right? Adding for all here like this is not breaking this pattern. What it's doing is it's introducing a new pattern on top of those, right? Because this can be logically extrapolated as a name, right? So obviously a name, especially for real, would have its own self-contained rules for how it's expressed separately from everything else, right? So by changing this, what I'm actually doing is I'm resolving the inconsistencies between the heuristics a for real that was encoded here and for real that was encoded everywhere else. So technically, what that should mean is that should work to control emergence better and help the LLM extrapolate patterns better, right? So let's see what happens. So remember, all of these, there's been inconsistencies in the pattern extrapolation. So let's see what happens now. What do you know? All right, so see what happened there? It copied the for real capitalization correctly while also copying the other patterns, not, well, obviously not correctly, but with the same consistent behavior that it did the other times, right? This is how you can see that this is working in terms of it correctly interpreted that rule difference, even though it's not still performing the pattern correctly, right? What we can do is, one, let's look at what it said, right? Who are you? So by probing it in this manner, what we're doing is we're simultaneously checking how the LLM interprets its own prompt at the same time, right? So all I define in here is that he explores the cosmos and has 3 starships, and yesterday he traveled to the Milky Way Express. That's the LLM's entire context on who this dude is, right? So because of that, if you force it to do something like this, right, you can start to probe out some more of emergent understanding, right? So what do we see here? A cosmic entity exploring the universe with his faithful spaceship. It was interpreted as he's like some kind of cosmic entity, right? So because of that, if I wanted to, right, I could just build upon this inherently in the following responses now, ping-ponging on top of that understanding in new ways. So for example, what I could do is I could come down here and be like, where do you originate, right? And it's, you can kind of know ahead of time, right? That's going to be building upon whatever it established in its last response to continue and propagate the narrative, okay? I originate from a star system near the edge of the Milky Way where energy flows in stars. See, right? This is what's cool. Since it already predicted behavior in the first response, right? It already learned what I was supposed to be doing in the first turn, right? So because of that, and because of ICL, you can build upon that, right? This is called stateful learning, where a state progression in the dynamic progression. Say this again. Where a state progression in the progressing hyperspace, right, which is how you can conceptualize on a mathematical level how the dynamic vector space is propagating as the response goes on. You can see how this works, right? Because it just needs to build upon what it came to determinations for in the prior state. Okay. You don't ever see this explicitly. This all happens behind the hood with how these predictive models work, right? They're constantly trying to extrapolate patterns, and if it already converged a pattern in a prior turn, it's going to just be able to immediately be able to build upon this, right? These are fundamental mechanics to large language models, and it's because of the learning algorithms they use and leverage in the first place in order to work and make these predictions, okay? So ICL is super powerful. Like, you can train anything with ICL. You just simply need to know that you can you simply need to know that you can do anything with ICL, and then know that if you can't do it yet, you just haven't captured enough context or dimensions, or you haven't built out your program in a sense, which is your prompt, to be able to project this more emergent understanding, right? So there's so many different things that can be done with this in general, right? All I've done here is encode 2 very, very, very basic chain of thoughts for a dialogue with 1 or 2 patterns encoded inside, and then shown you how the LLM can project from that to do different things, right? I mean, this is how people make personas, stuff like that, right? They kind of encode unique perspectives, put it in an engine, and then create like a pattern engine, right? This is how a lot of different behavioral engines with LLMs work in general, right? You give it a couple examples for it to learn, and then when it responds after that point, it's going to be building upon that, right? The most important thing is understanding how emergence works and how inconsistencies in data accrue emergent complexity, and the LLM starts making up its own rules for them as it goes, right? What we can test here is I'm going to take this and I'm going to go to Gemini. I'm going to put this in here too. All right, let's see what happens. All right, you can see how basically instantly learned the stuff in comparison to chat, right? But something to notice here is that there's still this inconsistency of this pattern, right? You see how this progressed between models into completely different models too. So even though, so this worked perfectly on mini, right? And produced an error in the projection. And even if we go to a way larger model that learns it better from the start, this is a more precise and clearly understood answer, right? It still has the issue here. Very interesting, right? There's something, I want you to see this because what you can see here is this is not actually due to the model, right? This is because of the patterns that are encoded here, right? So what's happening is that because this is just done in a way of this particular pattern, right? Like these 2-letter and 1-letter words are throwing it off because there is not enough logic or context here for it to be able to actually predict it. I would predict that if I was to go same. I was to do that, I was able to spell. Okay. What I'm doing here is I'm providing context, explicit context, on what the pattern is, okay? On top of providing the pattern. So what I'm going to do now is I'm going to see if this works to fix it, okay? All right, let's see what happened. For real am a conscious being seeking to explore, understand the universe. So what you can see a couple of things here, right? This provided context on what it is, even though it wasn't in the examples, right? Since I had context, if you have context anywhere, right? Anywhere on what these extrapolations are, it's all going to work to improve the understanding of what this projection is supposed to be, okay? So even though I provided context here on what this is, it still did not do it right? Now, why is this happening in reality, right? Reality is because these models are trained on tokens, right? They see tokens, right? So they can't actually see the exact patterns that I am encoding here with the capitalization, right? It's getting tokenized slightly differently, and that's causing inconsistencies in how it's interpreting it, right? So it's giving it a slightly more complex response, right? And that's causing emergence. So let's test this now with this defined now. Delete these. What happened here? Hmm? What happened here? Well, the only mistake it made is it didn't capitalize the second M or the second letter in AM, right? Everything else actually did it properly this time. It correctly did the first and last letter of each word, and then did not add extraneous ones in there. So that was correct, right? Outside of that, you could probably attribute that to the tokenization, though. Okay, so this provided it context on what the right way to do this was, what the right interpretation of this was, even though it's tokenized slightly differently. Okay, very interesting. So now let's go back here. Let's take this out. So now that we know that this is not working here, but it worked on Gemini, let's see what else we can do to make this even better. What would happen if I encoded a response layer? And I forced it to reflect open-ended before it responded. What would happen then? Right? When you do that, you give it more time to understand what to do. Okay? However, as you can see, simply giving something more compute time before testing does not necessarily change or remove some of the limitations in understanding. So like if I didn't know any of this at all and didn't understand what was going on here, right? We know that this is an error because of the tokenization probably, right? And because of the specific pattern I'm encoding here, it's very likely not tokenizing the, for example, it's probably not tokenizing the to or some of the other words properly to actually be able to see the pattern here. And then that's causing emergence in the implicit patterns in its response as a result. Okay? So what to take from this is that increasing compute, like adding thinking tokens and reflection before some kind of projection doesn't necessarily mean you're going to get a better response or even a more accurate response, right? What will happen most often is that you will get a response with a higher complexity understanding, right? As a result of doing that. However, if there's dirty patterns, if there's inconsistencies in the data being projected, whether it's here in the explicit context on the surrogate side, or if there's inconsistencies in the trained data that is used to train the base model in the first place, right? What will happen is that you'll start getting inconsistencies in the projection, right? And you'll get patterns that break, but they're not really breaking. They're more evolving, right? They're evolving as the understanding evolves. Now, here's the thing. Since we did not establish perfect control over these patterns, we don't actually know what the rules that the LLM is using here. We also have no ability to ask it or to unravel that. It's technically impossible. The moment this generation ends, the LLM loses any ability to interpret patterns that it's throwing. If I was to ask in reflection, it would simply be guessing. Okay, it would not actually have any idea what it was doing here. To add, for example, an R here, but a capital E here, and then a capital R there, right? I mean, for all we know, it's following some pattern here where it's like positioning it in different spots, and it's impossible to tell, right? So this is the dual sword of ICL that gets almost everybody. This most important step to starting working with ICL is to establish clean, coherent, quality, foundational data knowledge, right? That you are certain is accurate and correct. And what you start doing is you start accruing examples and feedback and knowledge that is rich with meaning and patterns and relevance and diversity, right? and you start incorporating that into prompts or meta prompts, right? With engine-like behavior, and then you start using the interplay between these two elements to facilitate valuable emergence, right? So the best way for me to teach is by showing basic examples of the stuff while explaining the conceptual knowledge, okay? Because this is the foundation of all so many possibilities, okay, with ICL. Except this is a very straightforward and explicit way to try to do this, right? ICL takes place and manifests in so many ways. Anything that you're doing with prompt engineering, okay? It's very important to understand learning mechanics behind all of this and what we're really doing here with prompting a model, okay? The goal of prompting a model is to get it to learn what to do, to get it to learn what to do in the most complex way possible. Because the higher complexity understanding you're able to achieve with something, the more accurate the model is going to be in its predictions, okay? So I'm going to wrap it up here since this is going to be a long video, but this is the first part of exploring in-context learning, what you can do with examples and pattern propagation, what some of the inherent limitations and constraints of that are in terms of making sure you have coherent synergistic patterns throughout all of your examples, and show you the start of what is going to be a big era in language modeling because of just the insane potential and depth that this simple mechanic brings to everything. Okay? I hope this was useful for you guys, and hope you get a lot of insights from this because I'll be using this to be explaining a lot more stuff as well. Okay? Cheers.